All right, so when you graph, it might already be in factored form, which is, we'll go over, because we're going to have to factor this to graph, okay? But when you are in standard form, remember there's a couple of things that you can get really, really easily. You can get the y-intercept. So don't forget, to get the y-intercept, you need to make all the x's 0. When it's in factored form, you have to do that, okay? And I'll show you when we factor this. But for right now, when you make all the x's 0, all you're going to be left with is -3. So we know that this has a y-intercept at, this looks like it goes by 2s, 2, 4, 6, 8, 10, yeah. So -3 will be here. All right, so there's my y-intercept. Now my end behavior, if you remember, you're going to look at the leading term. So it's odd, so we know that it's going to end opposite. But because it starts with a negative, it's going to have a negative slope when we look left to right. So it'll be like this. So odd, opposite, and then the leading coefficient is negative, which is why it goes from up to down. We're moving in a negative direction overall, okay? All right, so now we need the x-intercepts and the behavior of the x-intercepts. The only way to get that is by factoring. So hopefully you're really good at factoring, but we're going to do our rational root theorem. I think -3 works, so I'm going to just go for it. And if it doesn't work, we wasted a little bit of time on synthetic division, but it's okay. But I'm pretty sure this is going to work. -3 times -1 is going to give me a +3. That's going to give me a 6, which is going to give me a -1, which is good. Yeah, we're good to go. All right, so we know that -3, so if I write it in factored form, I'm going to get an x plus 3, right? The root is -3, but in the factorial it would be x minus 3. All right, so now I have negative x squared minus 2x minus 1. Let's see real quick. I think -1 will work. Let's just give it a shot. So -1 times -1 is a +1. -2 plus 1 is a -1 as well, which is going to give me a +1. Yeah. So I have -x minus 1. All right, so putting this in factored form, getting all the information that I have, I know -3 is a solution. So remember that's going to be x minus 3. Sorry, x plus 3 when it's in the factor. X plus 1. And then we're going to have, and then this is the leftover, right? So I don't need to worry about moving anything around on that. Okay, so how would we, if it would have been in factored form, how would we have got the the y-intercept? Remember, we'd have to make every x 0. When you want the y-intercept, you just make your x's 0. So I'd end up with 3 times 1, 0 plus 1 is 1, and then -0 is 0, and 0 minus 1 is -1. So 3 times 1 is 3, 3 times -1 is -3, which we already knew the y-intercept was -3, okay? All right, so now, if you take a look at that, we are in factored form, right? So in order to find the end behavior, we basically ignore all this stuff, if you remember, and just multiply that. So we'd have -1 times 1 times -1. We'd have -x cubed, which is the same thing that we had earlier, right? Okay, so now we need our zeros. So we already know that this is going to become -3 because we did the synthetic division, right? And then this is going to become -1. Now this one, we got to be careful with our negatives. We're going to add 1. So -x equals 1, and then we're going to divide by a -1 to get the x all alone, and we have x equals -1. So this is happening twice, right? So we have multiplicity of 2. So we have an x-intercept at -3 and an x-intercept of -1, but remember it has multiplicity of 2. Okay, so what does that mean? Well, -3 has an odd multiplicity of 1, so it's going to cross through. Now, I don't know exactly how far it goes down, so I'm just taking an educated guess. But at -1, because it has an even multiplicity of 2, it's going to bounce off and then go through our x-intercept and all the way down. And that's how you graph.